Hello students, in this video we will be seeing solutions for previous year JEE question paper and we will be seeing the topic called kinematics. So this particular topic called kinematics is covered in the unit mechanics. So in mechanics part, if you see, we will be having different subdivisions. We will be having kinematics, and then we will be having laws of motion, and in kinematics we will be having kinematics in one dimension and two dimensions, that is the Cartesian coordinates only, projectiles, circular motion, uniform and non-uniform, and relative velocity. And if you see in laws of motion, you will be having Newton's laws of motion, inertial and uniformly accelerated frames of reference, static and dynamic, friction, kinetic and potential energy, work, power, conservation of linear momentum, and mechanical energy. And then we have the system of particles, laws of gravitation, rigidity body, moment of inertia, torque, angular momentum, conservation of angular momentum, and collision of point masses with rigid bodies, linear and angular simple harmonic motion, Hooke's law, Young's modulus, pressure and a fluid, Pascal's law, surface tension, Stokes law, streamline flow, equation of continuity, Bernoulli's theorem, and wave motion, longitudinal and transverse waves, beat and speed of sound in gas, and Doppler effect. So these are all the several topics which comes under the unit called mechanics. So all these subdivisions will be falling under a particular topic called mechanics. So in this video we will try to solve solutions for previous year JEE question paper, and we will be particularly focusing on kinematics, which covers kinematics in 1 and 2 dimensions, Cartesian coordinates only, projectiles, circular motion, uniform and non-uniform, and relative velocity. Okay, let us now see the first question. A particle is moving with a velocity v is equal to k yi plus xj, where k is a constant. So the general equation for its path. So you have to find out what is the general equation for its path. So you take Vx by Vy, Vx by Vy is equal to dx by dt divided by dy by dt. Okay. So here you know dx, the dt and dt will get cancelled. So dx by dy will be dx by dy will be equal to ky by kx. Okay, so or it is equal to y by x, dx by dy is. Now you take this x this side, it will become x dx is equal to y dy. Now you integrate this, you will be getting it as y square is equal to x square plus a constant. Okay, so the correct option is option number D, y square is equal to x square plus constant. Okay, so here they are saying a particle is moving with a velocity v is equal to ky I plus xj. Okay, and where k is a constant. So here you are taking v is equal to vx is equal to dx by dt and dy by dt, dx by dy. So if you differentiate this equation, you will be getting dx by y is equal to, dx by dy, it is dx by dy is equal to y by x, and when you integrate that, you will be getting the general equation for its path, which is equal to y square equal to x square plus a constant. Okay, let us now move on to the next question. In three-dimensional system, the position coordinates of a particle in motion are given below. X is equal to a cos omega t, y is equal to a sin omega t, and z is equal to a omega t. The velocity of the particle will be. So you will be having r is equal to xi plus yj plus zk. Okay. So now you have to substitute the values of x, y, and z. So r is equal to a cos omega t I plus a sin omega t j plus a omega t k. Okay. So, this is k. So, now you take this a as common, r is equal to a into cos omega t I plus sin omega t j plus omega t k. Okay. So, we know that the velocity v is equal to dr by dt. So, you differentiate this with respect to dt, you will be getting it as v is equal to cos omega t will become minus a sin omega t, sorry, minus omega sin omega t. So, already one a is there, so it will go inside, minus a omega sin omega t I plus a omega cos omega t j plus a omega k. Okay. So, the velocity of the particle will be minus a omega sin omega t I plus a omega cos omega t j and a omega k. Now, you want to find out the magnitude of the velocity. So, the magnitude of velocity is given by root of v x square plus v y square plus v z square. Okay. So, you will be writing this as v is modulus of v is equal to root of v x square is minus a omega sin omega t, I component. Okay. So, the whole square plus a omega cos omega t the whole square plus a square omega square. So, you know sin square plus cos square will become 1, and you are having here one a square omega square and here one a square omega square. Okay. So, you will be having, on solving this, you will be having it as you will take a omega outside. Okay. So, this a omega square plus a omega square, it will become square root of omega a. So, the velocity will be square root of omega a. So, the correct answer is option number A, square root of 2 omega a. Okay. So, you are just writing the equation for r equal to xi yi yj plus 2k. So, x is a cos omega t, y is a sin omega t, and k is z is a omega t. That is what they have given in the question. And if you differentiate that, you will be getting one equation. In that equation, you are finding out the magnitude of the velocity, and when you solve this, you will be getting the velocity as root 2 omega a. Okay. Let us now move on to the next question. Two guns A and B can fire bullets at speeds 1 km per second and 2 km per second respectively. From a point on a horizontal ground, they are fired in all possible directions. The ratio of maximum areas covered by the bullets on the ground fired by the two guns is. So, the bullets from guns can reach up to a distance of maximum range, which occurs when projection is made at an angle of 45 degrees. Okay. So, at 45 degree, what happens is R1 is equal to U1 square by G, and similarly R2 is equal to U2 square by G. Okay. So, the ratios of R1 and R2 will be is equal to pi R1 square by pi R2 square. Okay. So, which is equal to U1 power 4 by U2 power 4, because G and G will get cancel each other. Here they are given you the U1 value as 1 kilometer per second and U2 as 2 kilometer per second. So, the ratios will become a ratio of areas will become ratio of the areas will become 1 by 16. So, which is equal to 1:16. So the correct answer is option number B. The ratio of maximum area covered by the bullet is 1:16. Okay. So here R is given by U1 square by G and R2 is given by U2 square by G, and here you are finding out the ratio of the maximum area covered. So it is it will be in a circular shape. So you are using the formula pi r square. That's why pi r1 square by pi r2 square, and you know what is r1 and r2. You are substituting, and they have given you the speed u1 and u2 value. You are substituting, and you are finding out the ratio of the maximum area covered, which is equal to 1:16. Okay. So let us now move on to the next question. A body is projected at t equal to 0 with a velocity 10 meter per second at an angle of 60 degree with the horizontal. The radius of curvature of its trajectory at t is equal to 1 second is r. Neglecting air resistance and taking acceleration due to gravity g is equal to 10 meter per second square. The value of r is. So here the components of velocity, components of velocity at t is equal to 1 seconds r, Vx is equal to u cos 60 degree, which is equal to 5 meter per second. Okay. And Vy is equal to u sin 60 degree plus minus g into 1. Okay. Since they are neglecting the air resistance and they are taking the acceleration due to gravity as g equal to 10, you are substituting that. So if you solve this, you will be getting it as root of 5 root 3 minus 10. Okay. So the modulus of Vy will be equal to modulus of 10 minus 5 root 3 meter per second. So now the angle made by velocity vector with horizontal will be, so if you draw a figure, you will be getting it like this. Okay, this is the x direction and this is the y direction. You are having it like this. Okay, so this is moving at the speed v and this is r, and here you will be having a alpha and here you will be having alpha. Okay, so you have to find out the angle alpha. So first tan alpha, modulus of tan alpha is equal to Vy by Vx. So which is equal to 10 minus 5 root 3 by 5, or it is tan alpha is equal to 2 minus root 3, or alpha is equal to, if you solve this, you will be getting it as 15 degree. Alpha is 15 degree. Now you have to find out what is the value of r. Okay, so r alpha is equal to an is equal to v square by r, so which is equal to g sin alpha, or r is equal to v square by g cos alpha. So you know what is the value of v and you know what is the value of alpha. If you substitute, you will be getting the r value as around 2.8 meters. Okay, so the correct answer is option number B, 2.8 meters. So first thing what you are going to do is you are going to find out the components of the velocity at a time t equal to 1 seconds. You have to find out Vx and Vy, and then you are finding out the modulus of Vy, and you are next finding out the angle made by the velocity vector with the horizontal. So that is tan alpha is equal to Vy by Vx, and you are finding out what is the angle. Alpha is 15 degree, and then with the value of the alpha you can easily find out what is the radius. Okay. The next question is the trajectory of a particle or projectile near the surface of earth is given by y is equal to 2x minus 9x square. if it were launched at an angle theta naught with speed v naught, then what will be the value of theta naught? And here they are telling us to take g value as 10 meter per second square. Okay. So, the equation of the trajectory of the projectile is given by y is equal to 2x minus 9x square. So, in projectile motion, the equation of trajectory is given by y is equal to x tan theta naught minus g x square by 2 mu naught square cos square theta naught. Okay. So, comparing these two equations, you can find out easily tan theta naught is equal to 2 and g by 2 v naught square cos square theta naught is equal to 9, or v naught square is equal to g by 9 into 2 cos square theta naught. Okay. So, you can draw the diagram like this, and this is theta naught, and here it is 1 and here it is 2 and here it will be root of 5. Okay. So, you can substitute the values and you can easily find out what is the value of this, and you know that cos theta naught will be equal to 1 by root 5. So, v naught square will be equal to 10 into cos square it is. So, cos theta naught is 1 by root 5, cos square is 1 square by root of 5 square. So, it will be root of 5 square divided by 2 into 1 into 9. So, if you solve this, you will be getting the v naught value as 5 by 3 meter per second. So, theta naught will be equal to cos inverse of 1 by root 5. Okay. So, it is a very simple problem only. So, v naught is 5 by 3 meter per second and theta naught is cos inverse of 1 by root 5. So, the correct answer is option number C. Okay. So, let us now move on to the next question. A shell is fired from a fixed artillery gun with an initial speed u such that it hits the target on the ground at a distance r from it. If T1 and T2 are the values of the time taken by it to hit the target in two possible ways, the product T1 and T2 is. So, here at theta and 90 minus theta ranges are same. So, r is equal to u square sin 2 theta by g, and T1 is equal to 2u sin theta by g, and T2 is equal to 2u sin 90 minus theta by g. Okay. So, this will become 2u cos theta by g. So, from these three equations we can say that T1 into T2 is equal to 2r by g. Okay. So, it is 2r by g. Okay. So, the correct answer is option number D. The product of T1 and T2 is 2r by g. The next question is a passenger train of length 60 meter travels at a speed of 80 km per hour. Another freight train of length 120 meter travels at a speed of 30 km per hour. The ratio of time taken by the passenger train to completely cross the freight train when they are moving in the same direction and they are moving in the opposite direction. So, you know that the time period t is equal to L1 plus L2 by the relative velocity. Okay. So, t is proportional to L by v relative, the relative velocity. So, T1 by T2 will be equal to 80 plus 30 divided by 80 minus 30. Okay. So, if you solve this, you will be getting it as 110 by 50 or it is 11 by 5. So, T1 by T2 is equal to 11 by 5. Because we are taking, they are moving in the same direction and opposite direction as the condition, and you are getting the velocity as 80 plus 30 and 80 minus 30. So, 110 by 50. So, you will be having the ratio of T1 and T2. Time taken by the passenger to completely cross a free train will be 11 by 5. So, the correct answer is option number C. Okay. Let us now move on to the next question. A person standing on an open ground hears the sound of a jet aeroplane coming from north at an angle 60 degree with the ground level. But he finds the aeroplane right vertically about its position. If v is the speed of sound, then speed of the plane is. Okay, so you can draw a diagram for this for better understanding. Like here you are having the north to south, and here the aeroplane is going, and this is position P2 and this is P1. Okay, so here the person is standing and you mark him as A. So, from here to here is able to see that. So, A, and this angle is 60 degree and this is V, and this is the velocity of the plane, and this is the velocity of the sound. Okay, so let P1 be the position of the plane at t equal to 0. So, P1 is the position of plane at t is equal to 0. When sound waves started towards the person A, and P2 is the position of the plane observed at a time instant t. Okay, so P1 is the position of the plane at time equal to 0 when the sound waves started towards the person A, and P2 is the position of the plane observed at a time instant t as shown in the figure below. Okay, so as shown here you can see, and here you can use the angle. The angle is 60 degrees. That's what they have given you from north to south. So, the angle is 60 degrees. So, cos 60 degree will be equal to P1 P2 by P1 A. Okay. So, which is equal to the velocity of the plane into time t divided by v into t, or you know that cos 60 is 1 by 2. So, Vp by V is equal to 1 by 2, or Vp is equal to V by 2. Okay. So, the speed, if speed V is the speed of the sound, then the speed of the plane will be V by 2. So, the correct answer is option number D, V by 2. Okay. So, let us now move on to the next question. Ship A is sailing towards northeast with velocity v is equal to 30 I plus 50 J kilometer per hour. So, where I points east and J north, ship B is at a distance of 80 kilometer east and 150 kilometer north of ship A and is sailing towards west at 10 kilometer per hour. A will be at a minimum distance from B in. So, here considering the initial position of the ship A as origin, after time t, coordinates of the ship A and B are at a position 80 minus 10t, 150 and 30t, 50t. Okay. So, the distance between A and B after time t is given by d is equal to square root of 80 minus 10t minus 30 t the whole square plus 150 minus 50t the whole square. Okay. So, d square will be 80 minus 40 t the whole square plus 150 minus 50 the whole square. So, distance is minimum when d by dt the whole d square is equal to 0. Okay. So, you are going to differentiate this. So, d by dt of 80 minus 40 t the whole square plus 150 minus 50 t the whole square. So, which is equal to 0 because d by dt d square is 0. So, if you solve this, you will be getting it as 2 into 80 minus 40 t minus 40, sorry, not minus, minus will be coming inside, minus of 40 plus 2 into 150 minus 50 t into minus 50 is equal to 0. So, when you solve this, you will be getting the t value as 2.6 h. Okay, it is a simple mathematics, you can solve it and you will be getting the value as 2.6 h. So, the correct answer is option number B, 2.6 h. Okay. Let us now move on to the next question. The stream of a river is flowing with a speed of 2 km per hour. A swimmer can swim at a speed of 4 km per hour. What should be the direction of the swimmer with respect to the flow of the river to cross the river straight? So, here the velocity of the swimmer is given by Vs is equal to 4 km per hour and the velocity of the river is given by 2 km per hour. So, the angle of the swimmer with the flow of the river, you can draw a diagram like this. Okay. So, here you are having the velocity of the river and the swimmer. So, here it is Vs and this is VSR. Okay. So, that is the angle is theta and this is the velocity of the river. So, here alpha will be equal to 90 degree plus theta. Okay. So, this is VR. So, the angle of the swimmer with the flow of the river is alpha as shown in the figure. You can see it is alpha and sin theta is equal to VR by VSR. Okay. So, which is equal to 2 divided by 4 or which is equal to 1 by 2 because VR is 2 and VSR is 4. So, that is what we have written. So, VSR means the velocity of the swimmer. Okay, you can change it to VSR for better clarity. And if you solve this, theta will be equal to sin 30 degree because 30 degrees because sin inverse of 1 by 2 is 30 degrees. So, you will be getting this. So, you have to find out what is alpha is. Alpha will be equal to 90 degree plus theta. So, alpha will be equal to 90 degree plus 30 degree. So, which is equal to 120 degree. So, the direction of the swimmer with respect to the flow of the river to cross the river should be 120 degrees. So, the alpha will be 120 degrees. So, the correct answer is option number B. Okay. Let us now move on to the next question. A particle moves from the point 20i plus 2i plus 4j meter at t equal to 0 with an initial velocity 5i plus 4j meter per second. It is acted upon by a constant force which produces a constant acceleration. What is the distance of the particle from the origin at the time 2 seconds? So, here the initial position of the particle r naught is equal to 2i plus 4j and the initial velocity of the particle u is equal to 5i plus 4j. So the acceleration is given by a is equal to 4I plus 4j meter per second. Okay. So the position of the particle at a time t is given by r is equal to r naught plus ut plus half at square. So t is equal to 2 seconds. So r will be equal to 2I plus 4j plus 5I plus 4j into 2 plus half into 4 into 4I plus 4j. Okay, because t square will become 4. So if you solve this, you will be getting it as r is equal to all the I components, you bring it to one side, to 2 plus here you have 10 plus here you have 8 I plus j components 4 plus 8 plus 8j. So when you solve this, you will be getting it as 20I plus 20j meters. Okay. Now the distance of the particle from the origin is given by modulus of r is equal to square root of 20 square plus 20 square. So this will be 20 root 2 meters. So the distance of the particle from the origin at a time 2 seconds is equal to 20 square root of 2 meters. So the correct answer is option number B, 20 square root of root 2 meters. Okay, let us now move on to the next question. The bob of a simple pendulum has mass 2 grams and a charge of 5 microcoulomb. It is at rest in a uniform horizontal electric field of intensity 2000 volt per meter. At equilibrium, the angle that the pendulum makes with the vertical is. So here forces on the bobs are shown as, you can draw the diagram of that, and this angle is theta and this is the bob. So you can see you will be having the forces, the components t cos theta, and this will be t sin theta, and the acceleration due to gravity you will be having it as mg, and the charge over here QE. Okay, so this angle is theta, and this is the electric force. Okay, so here for equilibrium we have t cos theta will be equivalent to mg and t sin theta will be equivalent to QE, the electric force. Okay, so when you divide these two, you will be getting it as tan theta is equal to QE by mg. Okay, and here they are giving you the Q value as 5 microcoulomb or 5 into 10 power minus 6 coulomb, and the E value they have given you as 2000, and the M value is 2 grams. So you know the values of G, so you can substitute here. G is 10, that's what they have given you here. So you will be getting it as 2 gram, it is, you have to convert into kilograms, so it will become 2 into 10 power minus 3 kg. Okay, so you substitute all the values here. Tan theta will be equal to 5 into 10 power minus 6 into 2000 divided by 2 into 10 power minus 3 into 10. So when you solve this, you will be getting it as 1 by 2, or which is equal to 0.5, or theta is equal to tan inverse of 0.5. Okay, so the correct answer is option number D, tan inverse of 0.5. So the angle the pendulum makes at the with the vertical is tan inverse of 0.5. Okay, let us now move on to the next question. A particle is moving with a speed v is equal to b root x along positive x axis. Calculate the speed of particle at time t is equal to tau. Assume that the particle is at the origin t equal to 0. Okay. So, here they are given speed is equal to b root x. So, if you differentiate with respect to time, you will be having dv by dt is equal to d by dt b root x. Okay. So, we know that dv by dt is equal to a. So, you will be having a is equal to b by 2 root x into dx by dt. Okay. Or you can write this like rearrange this, and you can write dx by dt is v. So, you can write that as b by 2 root x into v, and v is equal to b root x. So, you can substitute that, you will be getting it as b square by 2. A is equal to b square by 2. As acceleration is constant, we can use that v is equal to u plus at. Now, it is given that x equal to 0 and t is equal to 0. So, the initial speed of the particle u will be equal to b root of x, or which is equal to b into 0, and it is 0. When time is equal to tau, speed of the particle is given by v is equal to u plus at. So, here u is 0 plus a is b square by 2 into tau, or you will be getting the velocity as b square tau by 2. Okay. So, the velocity is the speed of the particle is b square tau by 2. Option number B is the correct answer. Okay. So, this is the first condition where you are taking x equal to 0 and t equal to 0. So, here they are given, assume the particle is at origin and t is equal to 0. That is why equal to 0 and t is also equal to 0. You are getting the value of u, which is equal to 0, and then at time equal to tau, you are substituting and calculating what is the speed of the particle. Okay. So, u is 0 and b square by 2 into tau, you will be getting b square tau by 2. So, the correct answer is option number B. Okay, let us now move on to the next question. Two stones are thrown up simultaneously from the edge of a cliff 240 meter high with initial speed of 10 meter per second and 40 meter per second respectively. Which of the following graph best represents the time variation of relative position of the second stone with respect to the first? Assume stones does not rebound after hitting the ground and neglect air resistance. Take g equal to 10 meter per second square. So, here you can see two stones are going up and coming down. Okay. So, they are thrown simultaneously. So, you will have a graph like this, 240 meters, and this is the first stone which is going at a speed of 10 meter per second, and this is the second stone which is going at the speed of 40 meter per second. Okay. So, this is the positive and negative. Okay. So, first we will find out at what is the time of collision of these two stones. So, S is equal to ut plus half at square. So, which will be equal to minus 240 10 t1 minus half into 10 t1 square. So, when you solve this, you will be getting the value of t1 as 8 seconds. Similarly, minus 240 is equal to 40 t2 minus half into 10 into t2 square. So, we will be getting the value of t2 as 12 seconds. So, from 0 to 8 seconds, both the particles are moving under the gravity. Their absolute accelerations are same, equal to g. So, the relative acceleration is 0, or the relative motion is uniform. So, the relative position will change linearly. At 8 seconds, the first particle strikes the ground, its acceleration becomes 0. Okay. So, the first particle is striking the ground at 8 seconds and its acceleration becomes 0, and the second particle has reached its initial position and is moving downwards, so the relative position will also now decrease. Okay, so the relative position will decrease, the particle is still in here, so its acceleration is g, or the relative acceleration is g. So the graph here which is having a parabolic representation is the correct one. Okay, so since one particle hits the ground at 8 seconds and the other one it takes some time to come and hit the ground, you will be having the graph with a parabolic representation. So the correct answer is option number B. Okay, so what you are doing is, here they are telling us two stones are thrown up simultaneously and they have given you the speed of the stones, at which speed it's traveling, and it is when it is coming and hitting the ground, what happens, how which of the graphs represents the time variation of the relative position. That's what they are asking you. So if you see, up to 8 seconds it is having a linear variation, and after 8 seconds one stone comes and hits the other stone, the second stone will reach its initial position and moves downwards, so the relative position will decrease, but still the particle is in air, so its acceleration is g. Okay, so because gravity only pulls the stone down, so the acceleration is g, so the graph will be having a parabolic representation. So it will be having a parabolic representation, it comes down like this. Okay, so the correct answer is option number B. Okay, let us now move on to the next question. From a tower of height h, a particle is thrown vertically upwards with a speed u. The time taken by particle to hit the ground is n times that taken to reach the highest point of its path. The relation between h, u and n is, so here time taken to reach the maximum height is given by t1 is equal to u by g, and time taken, if t2 is the time taken to hit the ground, you will be having minus h is equal to ut2 minus half g square t2, or t2 is equal to n u1. Okay, that's what they have given you. So t2 is equal to n u1 because it is n times the taken to reach the highest point of its path. So n u1. So you can substitute the values of that t2 here. You will be getting it as minus h is equal to u n u by g minus half g n square u square by g square. Okay, so this is g over here. Okay, because we know that t1 is equal to u by g and you are substituting that values over here. So you will be getting it as minus h u n u by g minus half g n square u square by g square. So you will be getting it as minus h n u square by g minus half into n square u square by 2g. So when you solve this, you will be getting it as 2gh is equal to n u square n minus 2. Okay, so the correct answer is option number C. 2gh is equal to n u square into n minus 2. Okay, let us now move on to the next question. A projectile is given an initial velocity of I plus 2j meter per second, where I is along the ground and j is along the vertical. If g is equal to 10 meter per second square, then the equation of the trajectory is. So the initial velocity is given by I plus 2j meter per second. So the magnitude of initial velocity is given by root of ux square plus uy square. So which is equal to 1 plus 2 okay, because here the I component is 1 and j component is 2. So, you will be getting the magnitude of initial velocity as root 5 meter per second. Okay. So, the equation of trajectory of projectile is given by y is equal to x tan theta minus g x square by 2 u square into 1 plus tan square theta. Okay. So, we know that tan theta is equal to ux by uy, sorry, uy by ux, so which is equal to 2 by 1 or which is equal to 2. So, you are substituting the values over there. Y is equal to x is x into tan theta is 2 minus g is here 10. Okay, they are given you as 10 x square by 2 into 5, because root 5 u square is u is root 5. So, u square will be 5 into 1 plus 4, because tan square theta is 4. So, if you solve this, y is equal to 2x minus 5x square. Okay. So, the correct answer is option number B. The equation of trajectory is 2x minus 5x square. So, what you are doing is you are finding out the initial velocity first, I plus 2j, and then you are finding out what is the initial magnitude of the initial velocity, which is equal to root of 5 meter per second, and then you are substituting the values in the equation of trajectory of the projectile, which is the standard equation y equal to x tan theta minus g x square by 2 u square into 1 plus tan square theta. So, it is a standard equation. So, you can substitute the values in this and you can find out what is the what is the equation of its trajectory, which is y is equal to 2x minus 5x square. Okay. Let us now move on to the next question. A small block slides without friction down an inclined plane starting from rest. Let Sn be the distance travelled from t is equal to n minus 1 and to t is equal to n. Then Sn by Sn plus 1 is. So, the distance travelled in nth second is Sn is equal to u plus an minus half a. And here they are given you the initial velocity is 0, u is equal to 0. So, Sn by Sn plus 1 is equal to an minus half divided by a into n plus 1 minus half a, because it is Sn plus 1. Okay, it is a suffix. So, if you solve this, you will be getting it as 2n minus 1 by 2n plus 1. So, the correct answer is option number C, 2n minus 1 by 2n plus 1. Okay, let us now move on to the next question. A particle starts from rest, its acceleration a versus time t is shown in the figure. The maximum speed of the particle will be. So, here the area under the acceleration time graph gives the change in velocity. Okay. So, Vi is the initial velocity is 0. So, del V or the final velocity Vf minus Vi is Vf now, because Vi is 0. So, the change in velocity Vf minus Vi will be equal to Vf, or it will be the maximum velocity. Okay. So, maximum velocity is equal to area of graph. So, area of the graph is half into 10 into 11. So, you will be getting it as velocity, the maximum speed as 55 meter per second, because 110 by 2 is 55 meter per second. Okay. So, the correct answer is option number B, 55 meter per second. Okay. I think this video would have been useful for you to recall some of the problems relevant to the unit called kinematics. As I was saying you in the initial slides, kinematics falls under the unit called mechanics. And if you see in this kinematics, the majority of questions were coming from kinematics in 1 dimension and 2 dimensions, Cartesian coordinates only, and projectile motion, most of the questions were coming, and in circular motion, if you see uniform and non-uniform circular motions, questions were coming from that, and questions were also coming from relative velocity. So try to concentrate on these 5 topics mainly. One is kinematics in 1 dimension and 2 dimensions, Cartesian coordinates only, projectiles, circular motion, uniform and non-uniform, and last, relative velocity. Thank you for watching this video, and all the best for your examination.